Hi guys, greetings from Bulgaria. I'm Anton. It's really hot here. It's already summer and vacation time. However, I started working the last few days on the second edition of my C# book about design patterns and automated testing. And I started to work on a new chapter about running tests in parallel so that you can run them faster. And I got inspired about this new video from our course about xUnit, using xUnit for writing Selenium tests in C#. And let's just quickly review what we talked about until now. In the first module, we talked about what is xUnit and why you need to care about the different advantages. Then we discussed how you can set up a simple xUnit project in Visual Studio with all of the dependencies. We talked about the different attributes and how you can use them for Selenium testing and how you can benefit from that. And in the last, a little bit longer module, we looked into a really advanced topic, how you can run data-driven how you can create data-driven tests and how you can use the awesome Selenium for automating all of the different new cutting-edge web technologies such as Angular, React, and many more. And in the module today, we're going to talk about parallel testing and how this can help you to run your tests much faster. We're going to talk, of course, about the different advantages and the disadvantages of xUnit and how you can utilize them. Don't forget to subscribe to the channel to get notified about these awesome LambdaTest videos. Also, in the end of the video, in the description below, you will find all of the many resources and, of course, the source code. So let's get started. Just a quick reminder of what we automated the last time. I showed you this awesome practice website to do MVC, where basically, by the way, it's open source and free. It's just the same to-do application, but implemented for different web technologies, React, Angular, Knockout.js, and many more. And here's our project until now. We have this to-do test C# class where we use this inline data attribute mentioning the different technologies. We open them, then we add different to-do items. We check one of them and assert the left count. This is until now. Now, how we can run these tests in parallel using xUnit. Actually, running unit tests in parallel is a new feature of xUnit version 2. Before that, you were able only to run tests in different assemblies. There are two modes of running tests in parallel: parallel tests with runners and parallel tests in test framework. So we're going to talk about the second one. Basically, we will be able to run tests in these different test classes. And it uses, basically xUnit uses the concept called collections. One test class here is a collection by default. However, you can create a custom collection on top of, if you use this collection attribute. For example, here we can create this collection Chrome. If we put it again here, it will be the same collection, and basically these two classes will be run on a single thread. But again, by default, every class can be run on a different thread. Now, if you want to configure, since we are using .NET Core, if you remember the cross-platform version of .NET, not the .NET framework, you need to do a few stuff before you are able to run the tests in parallel. First, we need to create a JSON configuration file for the execution. It's called xUnit runner JSON. First, you need to search for JSON format, select JSON file, and we'll name it xUnit runner.json. And inside of it, we need to place this stuff: parallelizable assembly true, parallelizable test collections set to true. And also we need to make sure when you click here properties, you need to choose here copy always. This will copy always this particular file when you build the project, because we need it into the bin folder. Now, the next thing is that you need to use the parallelizable, you need to put a single attribute in one of your classes. Let's for now assume that we want to put it here. It starts with assembly, 2 dots, collection behavior, something. Actually it needs to be on top of the namespace here. You need only one of them. You don't need it in every class. And with this collection behavior, we are saying we are executing in parallel all of the classes, collection per class. And also I'm saying that the max parallel threads count is equal to 4. Most modern machines have more than 4 CPUs, so you're good to go, maybe up to 6 or 8 threads. However, let's start with something smaller, like 4 or 2. And now, I want to be able to execute these tests faster, because they're, if we look, if I build a project, you will notice that these data-driven tests, I think we have a lot of tests here, right? We have 22. However, since they're in a single class, we cannot run them in parallel. We need to split it. How we can split it? I propose, if we look here, you will see that we have an example written in pure JavaScript and compiled to JavaScript frameworks, so we can split them into 2 files. I will just copy this file and rename it to compile to JS to do tests. Here, as I said, we only need one. We need to rename the constructor as well. And here we are going to rename this to pure JS to do tests. We rename the constructor and the file. So we have these 2. I already, in order not to lose time, the pure JS technologies are these ones here, without the backbone here. And regarding the compile to JS, I also group them so that we can spare some time. Here they are. So we have the 2 of them, right? Here it is. 2 of them. Now, in the test explorer, you need to click here. I will just resize it a bit. Just wait a bit, wait a bit. Visual Studio is slowing down with these parallel options. Let's see what's happening. Okay, my mouse. I have problems with my mouse. So now, here from the settings, you need to choose run tests in parallel. And when you basically select this and this one, we can run them, right? And they will run in parallel. You will notice that both of them are running. There are 2 browsers and they're closing and everything. I will just stop the execution for now. But yeah, they're running in parallel, which is great. However, there is one huge problem. This is enough for running them in parallel. It will be fast enough. However, you will notice that everywhere we're repeating this initialization logic, which is not good. And actually, there is a concept in xUnit. It's called shared context between tests. It's common for system and UI tests to share setup and cleanup code. It's often called test context. And there are three ways how you can do this. In xUnit. We already looked into the first one, where basically when you implement the iDisposable interface in our tests, this dispose method will be called after each separate test, and the constructor will be called before. Actually, the dispose will be called after the test, which is the test cleanup, and the constructor will be called before the test, which is the test initialize, where we basically for every test we're restarting the browser. However, as you can imagine, especially this is relatively fast for Chrome, but for example, if you try it with Firefox, it's extremely slow. And sometimes, especially in enterprise projects where we have thousands of tests, we want to, and this initialization logic here is much bigger, so we want to reuse it. And in order to reuse this setup logic between classes, and also in order to reuse the browser between the different tests, but clean it once we're done with the tests in the class, there is a concept called fixture. And now we're going to create our first fixture. Let me show you what this is. I will just name this first version because later on we're going to improve it. And I will create a new class called driver fixture, where we're going to reuse how we initialize the browsers. I will make it public. I will implement a disposable interface, and what else? We're going to create two properties. One of them will expose the driver, my web driver. I will call this just the driver, and we'll need one more for web driver weight. And directly, I will call this web driver weight. And when you select them and press Ctrl dot, we can generate a constructor. Here it is. Actually, we don't need to accept any parameters, but instead we need to go to compile.js, and I will just copy this logic here. But here we are going to initialize the driver. We need to add usings for the driver manager, Chrome config, and the versioning, where actually we can always install the latest version of the browsers. Here we are initializing the Chrome, and here we need to initialize WebDriver weight, where we're going to paste that. And also I'm going to bring this constant for waiting for element timeout. And in the dispose, here we need to dispose, basically close the driver. Here I'm going to call the quit method. Now, how we use this driver fixture? Basically, the driver fixture again is something that it's going to be used and initialized only once for our tests in the class. In order to use them instead of all of this, what we need to do is to create basically here an instance of it. I will call it fixture. Also, instead of iDisposable, here we need to implement another interface coming from xUnit version 2, a class fixture. And here I need to provide the driver class fixture. And basically, I don't need this one anymore. But instead, we need to create the proper constructor. I will just generate it like this. Or we can use a body. And now everywhere, instead of the driver here, I'm going to use the fixture and use our new property called driver, right? Now, and here the driver weight, right? this is the refactoring. We need to do the same thing basically for the second test class, the pure JS. Here I will delete this code and the driver fixture, class fixture, driver fixture. I just need to add a using to it. Here it is. And change the constructor name. And everywhere we need to use driver. Now we need to use the driver weight. Here it is. Perfect. We reused all of the logic. Let me rebuild it. Let's see what happens. Again, I will rerun these tests. You will see that 2 browsers will appear. Here they are. And as you can see, the browser is not closing. And we're repeating all the tests, which is great. I'm stopping them again. However, there is one huge problem right now. And the problem is that everywhere we're using only Chrome, we cannot change it, right? And sometimes, you need to be able to choose different browser. Everything right now is hard-coded in this driver fixture. And I will create a folder for our second version, and I will show you how we can improve this. I will copy the driver fixture here. I will just change the namespace, second. And now we want to abstract this logic here in the fixture and create a class responsible for initializing properly, depending on some kind of a setting, how to initialize the driver. And I will show you another pattern, actually 2 patterns. We'll talk about the pattern adapter. And this is why I'm going to call this class driver adapter. Basically, this adapter, the adapter allows you, allows the interface of an existing class, in our case, iWebDriver, to be used as another interface. I'm in the resources below, you will find the detailed article. Right now, I'm going to implement a simplified version because we don't have so much time. Again, here we are going to implement the ITisposable interface. And so I'm going to move some of the logic right here in the adapter. Also, we are going to use the adapter instead of the iWebDriver. And yeah, also we're going to use composition. The composition means that we're going to use here the driver and the WebDriver weight. We're not going to expose them publicly. And we're not going to get them from a base class, but instead we're going to use them as private variables. This is another object-oriented programming technique for writing maintainable code. iWebDriver. So I'm going to create here a private variable called the driver. The same for WebDriver weight. And instead of here, I will comment that for a while. Also, all private variables will begin with underscore. Again, as I said, here we're not going to have that. Now, a second design pattern here. In order to easily be able to initialize the driver, we're going to use the design pattern called factory method. Factories, as you can get from the name, are classes or methods that can basically, we use them to initialize, create objects or initialize them, whatever. In this case, we'll have this factory method, basically a method that will produce or initialize the driver. Now, I'm going to call this method start. And we will need one more thing. I will create a new enumeration called browser type. This will be a public enum. And in this enum, I'm going to, basically we're going to have all the different browsers, right? Now, we're going to provide this in our adapter and into the factory methods. And we will have a switch based on this browser type. And here we're going to place our initialization logic, again, that we had before. Here is for the Chrome, we need all of the different usings. In order to spare some time, I'm just going to copy the rest of the initializations. As you can see, we're just initializing the different drivers and we're getting the latest version of them, right? Now, we'll go to the test and again, since we're not going to expose the driver and everything, we don't need this constructor anymore. Also, one more thing, in this start method, we need to initialize the WebDriver weight. And also, we can, here when we start the driver, we can maximize the browser, the windows, right? In order to easily see what's happening or not. What else? Now, we go here, we need to expose the go-to URL, and I'm going to copy this method, expose it publicly, and maybe this one with the WebDriver weight in our driver adapter. This one. Instead of wait and find, I will just name it find element. Instead of the driver fixture, here we need to use underscore driver. I need to add the using to expected conditions. And here again, underscore WebDriver. Now, they need to be public. And as I said, we need one more method called public void go to URL. It will accept a string. This will be our URL, right? URL, driver, navigate, go to URL, our URL. This is part one. Now, we need to refactor a little bit our driver fixture right now. We're going to make it abstract. And also in the driver fixture, here, instead of returning iWebDriver, here I will return driver adapter. And we don't need anymore this one here. Here we, instead of quit, we're going to call dispose, since the driver adapter is implemented as well. The iDisposable interface. Also, we're going to create one virtual property, which we can override for the different fixtures. I will call it wait for element timeout, which by default will be equal to our constant, but we will be able to change the timeout depending on the different, depending on the browser type, right? And here we need to create the adapter, but still it's not initialized, right? We need to call our special logic, right? And here I'm going to use another pattern. Here I will call initialize driver method, which I'm going to declare as protected abstract void initialize driver Actually, this is called a template method design pattern. And how you use this template design pattern, actually, we're going to have one child class for each browser. So here I'm going to create another class called Chrome driver fixture. It won't be abstract, but it will derive from our driver fixture. And it needs two things. First, when you press Control dot, you can implement it, the initialize driver. And actually right here, since this is Chrome, we just need to call the adapters start factory method with the browser type of Chrome. And also we can override, as I told you, actually this can be protected as well. The wait for element timeout. In this case, it can be 40. In case of Firefox, this should be even more. Now we'll have, as I said, one more class for Firefox driver fixture. And here, I'm going to change just Firefox. I'm going to change the seconds to 16. And we'll have one more for the Edge and Safari. Now this is Edge driver, and you can take it as a homework, one more for the Safari. Now, how we use this? Here I will create a subfolder with the tests. I will name this folder tests. And here I'm just going to copy these two files. Here I'll just change the namespace. And I'm going to show you actually how we can run the same tests for based on different browsers, right? Now, here I'm going to rename this to Chrome tests. I'm just going to rename it, right? And we're going to create one more of this class. And here I'm going to use Edge. We can do the same for pure.js to do tests. The difference now is that instead of driver fixture, here I'm going to use Chrome driver fixture, and I'm going to paste it here. As you can see, of course, since we are using the adapter, right now we don't have this. And right now, we can delete this validate because we moved it. Also the wait and find. And everywhere we need to change this with fixture.driver.find element. We need to change that, this as well. One more. Almost ready. And now we need to do the same for the Edge. As I said, we need to use the Edge driver fixture. We need to clean here a bit. We don't need the wait for element. Let me just reuse some of the code and copy it. I already did the same refactoring for you. Here it is. We can, for homework, you can do the same for the pure.js to do tests. Now I'm going to rebuild. Yeah, okay, I missed that one. Yeah, no more with this one. And this one as well. Yeah, you can do the same for the pure.js to do. Now I'm just going to delete it to spare some time. For the sake of the demo, you got it. Now we're good to go. Right now, as you can see, we have this compile to JS, Chrome, and Edge. I'm going to start them. And as you can see here, the tests are, maybe there is a problem with the initialization of the Edge, but anyway, yeah, there is a problem with my installation, but this is not important. It's just a problem on my machine with the Edge. But anyway, the problem here right now is that, as you can see, we just duplicated the tests, right? Still, we have copied these private methods. Maybe one way to do it is just to create a base test and reuse these private methods, marking them as protected. This is fine, but we won't be able to reuse this logic here. And actually, the next thing that I want to show you is that basically you can have as many class features as you want. Let me show you. We are going to create two more. We're going to use a few other design patterns. So I'm going to create one more folder with the third version. And here I'm just going to copy all of the files, but of course we'll need to change the namespace in order everything to be able to compile. And we're going to move all of this logic in page objects. As you know, page object is one of the most popular design patterns in test automation. Basically, it represents one page, all of the elements there, and all of the actions that you can do there. In our case, we have 2 pages. This is our main page, and then we have the to-do application page. These are our 2 pages. So we can create a new folder called pages, and I'm going to create a new class called name page. And here we can expose one property called, which is string. It can be URL, and here we can provide the URL of the page. This is just a getter. And if I go to the tests, you will notice that actually we need only these 2. This is our URL, so we need to move this to a method called open. This is the URL, and we can create one more public method, public void open. But here, of course, as you see, we don't have the driver, so we need to have, again, we are going to use composition. We can use the driver adapter, of course, if you want. Yeah, so we're going to have a private variable to the driver adapter, like this. Of course, we can generate the constructor again. Visual Studio can do that for us. Here we use expression body syntax for that. And here we just need to provide driver. Now we need to go to the tests and copy the, actually move this open technology method here. And here, of course, we need to use the underscore driver instead of the property. And we need to add a using. Here it is. And of course, this needs to be public. This is our first page. Now I can copy it and reuse some of it. Let's name the second to-do app page. I'll just copy the name, change the constructor name. So this is the logic. And what else? We need to get here the rest of the private methods and expose them publicly, right? So we don't have URLs or whatever. Here it is. I just need to make them public. And of course, instead of picture, we have the underscore driver everywhere. That's it. now we have pages. I'm going to show you one more pattern. It's called facade for the using the workflow, because right now we can move these two into the fixtures, but everywhere we're going to repeat this pattern. And sometimes you want to reuse the workflow. Sometimes you will want to have add more to-do items, right? So we will need to figure out how to do that, right? So I'm going to create, actually the facade is basically, you can think of it as a wrapper to the workflow. We are going to reuse the workflow and make our tests a little bit more user-friendly and maintainable. So regarding the facade, I'm going to create a new class and I'm going to name it to the facade. And here in this class, we'll have two read-only variables to our pages, main page, underscore main page. Of course, you need the using. And then we need to do a page underscore to do a page. When you select them and press Ctrl dot, Visual Studio will generate the constructor for you. And we can create a new public method, public voids verify to-do list created successfully. And we can move the whole workflow here. I can get the workflow from here. So here is our to-do facade. Just to see what we need to do. So first, we need to use the main page and open it. Then we need to call main page and then call open technology. But as you can see, it requires a name of the technology. So here I will move one parameter called technology and provide it here. And now we need to be able to add as many items as we want, and we want to make this a little bit more generic. So I will provide these items as a list of strings, items check, and we provide another list containing items to be checked. Actually, this is items to add, items to check. And the last piece is just to mention expected items left. Now, we can use a little bit of link magic. Link, it's like extension methods to different collections. So we have a functional programming syntax where you can provide anonymous methods called lambda expressions. You have the same, it's called stream API in Java. So here we mentioned the variable. This is actually each item in this for each loop. And then we can call the to-do up page and go add new to-do item. This is, as we hover, you can see that this is a string. And we can do the same for the check items, but we're going to iterate the other collection. And lastly, of course, the last part will be to use our to-do up page to call the assert left items. And we already provided this here. Now, as I said, we can have more than one fixture. And this is why I'm going to create a new fixture called pages fixture, where we're going to initialize the pages and everything. Pages fixture, here it is. It should implement iDisposable. This is requirement for from xUnit, right? iDisposable. Actually, in this case, basically this method will be just empty. But don't worry, this is fine. And now we need to expose the different pages. Probably we're going to use them from the facade, but anyway, here we'll have to do a page, and here we'll have to do facades. And now through the snippet vector, when you press tab, you can generate the constructor. We will need to create a new instances of the pages. However, as you can see, one major problem, our pages require the driver adapter, which is actually initialized in the driver fixture. We'll have to couple them a little bit. Of course, for more complex frameworks, etc., this is just a simplified version to show you some tips and tricks. In production, the code will be a little bit different, but anyway, I think you'll get enough patterns and concepts so that you are good to go. And again, for now, I will just provide no here, but we need to provide a meaningful version of the driver, right? And there is one big problem. This driver should be thread safe because we're going to access the same between the different threads. In order to do that, we will need to change a little bit our driver fixture, the base driver fixture here. Since basically every class, every collection will have a separate implementation of the driver fixture, we want to be able to access statically the driver. However, there will be a problem because the different threads will try to work with the same driver, right? Which is a problem, and we want for every thread and every process to have the different driver adapter. This is why we can use a special class which comes from .NET Core. It's called thread_local. Thread_local, you can think of it as a container for holding information. Basically, the thread_local is a container for holding instance of our class once per thread. And internally, it handles all of the complex logic between synchronizing between the different threads. So you're good to go, and basically, you will be sure that only a single instance will be created for the thread. Now, we need to change a little bit the constructor here. Again, this accepts Lambda, and it has something like a factory constructor where the first time we can initialize the new driver adapter once per thread. And when we want to actually get the value from this container, we need to use the value property here. And of course, everywhere in the driver adapter, it's fine, but here you will see that we cannot build it. We need to use the value, right? In the edge driver as well, and into the Firefox one as well. And now when we go back to our pages fixture, we can use the driver fixture dot driver dot value. Since again, this is thread_local, right? And we're going to use the same here. Now, if we want to use this pages fixture in our tests here, yeah, everywhere we will have to use the value, driver.value, but we can change it like this. When you press Control F, current document, we can change it like this everywhere, which is completely fine. Driver value. Now, what is it complaining? Yeah, actually, we no more actually need this stuff here. We're going to use our pages. This was the whole refactoring about, right? So we are going to delete this. Actually, I will just leave the data. But now we need to put another class fixture, pages fixture, and of course, here the pages fixture, underscore pages fixture. We need to provide it in the constructor. Here, we need to initialize it, of course. Now, of course, not like this, but we need to provide it, and we need to initialize this with the following thing. Now, if you want, first, we can use directly this pages fixture to do facade verify methods, and we need to initialize these two collections. I already did that. Here it is. Of course, we need to start using the system collections. And as you can see here, first we arranged what items to be added. This is really generic since you can add as many items as you want, and you can basically change the parameters. Every time we're going to reuse this logic for for the tests, right? Here, the only difference is that in this test here, we're going to, of course, this is the different name, and we have the implementation of as-class fixture pages. And here we need to use edge. That's the only difference, and we need the collections like here. We no more use the fixture directly because we basically, the pages are triggering it. But since we're doing the starting initialization in the constructor of the edge fixture, which will be created once for all of the tests here, we're good to go. We can do one last improvement. Since not every time we want to hard code this data, and as I told you, we can create as many class fixtures as you want. We can add one popular library for generating data. It's called AutoFixture. And this AutoFixture class, basically we can use it again for generating data. In a second, I'm going to show you. I'm going to create here another fixture, and I'm going to call it test data fixture. In this test data fixture, again, needs to be public, and it should implement the iDisposable interface. Of course, like before, in the dispose method, we're not going to do anything. And here, I'm going to create and expose three properties. One of them will be items to add, and items to check, similar names to the ones that we put into the arguments of our facade. And now we're going to initialize them, but in a different way. Let me show you. we're generating the constructor. In order to use auto-fixture, I'm going to use var fixture or auto-fixture, just to know that it's not connected to the xUnit fixtures. And now new fixture, no pages fixture, and we need to add the proper using control dot auto fixture. You need to add the using to this one. And now in this auto fixture class, it gives us new methods for generating automatically many items for us. This auto fixture has a method called create many. And I can say, since it's generic method, I can say create many strings, 5 of them, and then convert them to list. Now, since we want to check some of the items that we already added, of course, we need to get them. Right now, I will just basically check the last 2. In order to be able to do that, I can use again link methods. As you can see, they are implemented as extension methods, and I'm going to say skip string to list, and now items left is equal to 3. And how we use this? Basically, we are going to go to our tests now, and we are going to implement again iClass fixture, test data fixture. Of course, here, test data fixture, we need to supply this to the constructor. Of course, it should start with underscore. So underscore test data fixture is equal to test data fixture. And instead of providing this here, we can change it to be used directly from our like this, directly from our test data fixture, and this will be created once for all the tests, and we are using this creation logic, which is awesome. Again, in enterprise and production code, probably you can reuse some of these fixtures, but probably you will extract this logic to a special factory class, again using this design pattern that I already showed you called factory. This is it for now. You can try to do this on your own and work on it. You can download the source code below. Next time, we're going to, in the next video from our xUnit tutorial, basic tutorial for beginners in .NET Core, where I teach you how to write Selenium tests. We're going to talk about the awesome opportunity for running tests and in parallel and running them in the cloud. And we're going to talk about what cross-browser testing is. So don't miss it. It will be really awesome. Thank you. If you have questions, you can go to the LambdaTest.com and ask directly in the chat. Also, you can check the awesome blog of LambdaTest, where you can find some of this information there. They're really long and nice articles. And also don't forget that you can get certification about Selenium. See you soon in the next video from our series. Bye.